Example 15, a certain first order reaction has a half-life of 20 minutes. So we already know it's first order, so we don't have to worry about graphing it. We're going to go on and calculate here. So we know it's first order, so we're using all of these. First order, by the way, is the most common reaction type. So we're going to use this row here for any of our formulas. It says calculate the rate constant. Calculate the rate constant for this. Okay, so we're looking for K. Our formula, only thing that we can use half-life is this column, so we have to be using this piece right here. So T to the half-life, remember T subscript half-life, or half means half-life. When it's just a T, it's time, but this is half-life equals 0.693 over K. We know our half-life is 20 minutes. Yes, a half-life is going to have a unit of time, but time and half-life are not the same thing. Okay, I'll put this over 1 and cross-multiply, and then divide both sides by 20 to get our K. Now we have our K to use for prop pieces going forward. All right, how much time is required for this reaction to be 75% complete? Now, anytime you have a percentage, you must decide if the percent represents percent remains or percent used. So think about it, 75% complete, if the reaction is 75% complete, then 75% of it has been used. So that's not remains. Kind of got to think of it in terms like that. So we have to figure out what to do to get to our remains. So remains is 100 minus used or complete. To get to amount of remains, if we know how much is left over, we take our 100% that we start with, or 100 that we start with, and subtract what we used, then we know how much is left over. So we're going to take 100 minus 75, and we have 25%. Remember that percent remains is A over A naught. So A over A naught, we got to write percent as a decimal to use it in a calculation. So 25% moved by decimal twice, 0.25. And then we're going to go from here. I'll explain this part here as we go to the next piece. Again, we know this is first order, so we know we're still using this row here. And we're going to use this formula then. And we are going to plug our K in. We're looking for time. We know we're solving for time. And how did I get this? Well, in order to use this, I needed to get A naught over A. And remember I said I'd come back to this. Well, we know percent remains is A over A naught. A over A naught equals percent remains. If I take the reciprocal or flip both of them, flip this, wouldn't this be over a 1? And if I flipped it, 1 would be on top. So A naught over A, 1 over 0.25. Now I have an A naught over A that I can plug in here. So I plug this in right here. I can crunch this out on my calculator. And I get 1.386 by hitting ln and put this in my calculator. So we are not EXing both sides. I don't have anything trapped. So I can just use my calculator. I drop this down. I divide both sides by 0.0347. And I get 39.94 minutes. Okay, how much time is required for 0.252 molar sample to have 43.0% remains? I have a percent. Anytime you're given a percent, you need to decide if it's percent remains or percent used. Nice enough, it told us remains. So we know it is remains. And so we can say percent remains is A over A naught. So A over A naught equals 0.43. Remember, we got to write this as a decimal. I'm going to put this over 1 and cross multiply. So put this over 1, cross multiply, get A equals 0.43 times A naught. We know our A naught, 0.252. So I plug that in, and then I can get an A. So now I have both concentrations. Because of the percentages, I was able to get both concentrations. So we know we're using this formula. We already know our K from the previous work we've done. We're going to put our A naught, which we were given, 0.252, and our A, 0.108, which we calculated through this work that I described a moment ago. We can crunch this into our calculator and get divide these two, and we get 2.33. We take the ln of 2.33 and get 0.847. Then I'm going to divide both sides by 0.0347 and get 24.4 minutes of time. Again, I highly recommend that you go through this with your calculator. Look at the parts and make sure everything makes sense so that you can duplicate this on your own examples later in your homework.